Good morning, everyone, and welcome to the European Shallow Geothermal Days 2021. The event is supported by the following initiatives and projects, which are EGEC, Renewable Heating and Cooling Platform, GeoDrainNet, the Geothermal DHC, the Project Muse, and Euro Geosurveys. My name is Constanze Choke from Geoenergiekonzept, a consulting company from Germany, and I will guide you through today's session. We will wait 2 more minutes until more people can join, and then I will present you our agenda. So people are still joining to our session today. And I think in 1 more minute we will start. So welcome to all the new people joining our session today for the European Shallow Geothermal Days in 2021. Our topic today is breakthroughs in shallow geothermal technologies. First, we will have a presentation by David Gattermann, the chair of geology at the Friedrich Alexander University Erlangen in Nuremberg, about 5th generation district heating and cooling networks. He's followed by Javier Ochoreguia from the University of Valencia and the chairman of the geothermal panel about updates on technologies, geothermal cooling, heat pump materials, and drilling. Followed by Ignacy Herms, the head of area of Geological Resources, Cartographic and Geological Institute of Catalonia, about the progress in the development of shallow geothermal energy market in Catalonia. And last but not least, Bas Gottschalk, the business developer at HT Atheist and international projects at Atheist Technology, about open loop systems and ATES, which potential. So good morning, everyone, and I will give the presenter motors to David.
Okay, thank you very much. Can you see my screen?
Yes, all is perfect.
Okay, perfect. So yeah, thank you very much. I just want to introduce you to the 5th generation of cold district heating and cooling networks, and these networks combined with shallow geothermal energy. So when we look at the content of my presentation, first of all, I want to talk about the low temperature district heating and cooling, then about very shallow geothermal potentials, and also large scale geothermal collector systems. Then I want to give an example of a collector based 5th generation low temperature district and cooling network, and in the end I would give an outlook of a planning tool where you can plan the first steps for these applications. So for the background, when you focus on cities, cities have a high demand of energy, so they have a significant impact also on the climate change. And this was the idea in former times also to develop the district heating system. So when you have areas with a high density or with a more very much popular region, you can use these systems. And at the moment, we have all in all 5 generations of these systems, in very rough, but you can divide them up into 5 groups. And within the 4th generation, it's possible to use renewable energy sources like shallow geothermal, for example. Here you see the different steps in the development of these temperature or these low temperature energy sources. And when you look at the graph, I think it's very important to see the development when you look at the temperature level expressed by the red line. You see that there was a increase or decrease from 200 degrees up to 0 to 20 degrees. So this is the 5th generation, and at the same time the energy efficient goes up. So this is only to keep you in mind what different district heating systems are developed on the market. And as I said before, at the moment we are in the beginning of the 5th generation. So when we look more in detail, which you see here, you can see, I will focus on the 5th generation. You can see the temperature level, as I said before, is 20 degrees up to 0 degrees. The heat carrier is antifreeze in this case, and the heat transfer will be provided by heat pumps, and the common heating systems are floor heating. So these are the basics for this 5th generation. As I said before, very shallow geothermal is suitable for this 5th generation of networks. And here you see it's suitable for very shallow geothermal sources up to 10 meter depth, and also for shallow geothermal up to 400 meter depth. So this can feed this 5th generation of the networks. Yes. When you look at the very shallow geothermal potential, normally it's driven by 2 main parameters. First, the physical soil parameters like the grain size or the soil texture, and the water content and the bulk density. And on the other side, the climate. And here you have the solar irradiation and the precipitation, which is very important for providing or calculating the potentials. And here you see a large-scale geothermal collector system feeding a 5th generation district heating and cooling net. It's also possible to use the collector in different layers, and compared to vertical drillings, you have lower installation costs and also lower by the government. There's also a lower range of installation requirements, for these systems. Okay, so when you look at the systems itself, I put some different special forms like heat baskets or capillary tube mats or slinky collectors. So all these systems are suitable to feed this 5th generation of district heating and cooling nets. There's also possible, not only these nets are related on geothermal sources, you can also use other sources like seawater, groundwater, river lakes, or solar, for example, just to give you an idea what is possible. Now I want to show you an example of a 5th generation district heating and cooling network fed by a very shallow geothermal application, like a collector system, which you see here. It's a project. We also involved in, this is a small village near Frankfurt called Bad Nauheim. And here you see this is a farmland. And there was also a big collector system installed. So you have a double use. You can use it as farmland now. It's also used as farmland and as source for the 5th generation district and heating cooling network. Okay, some basics. All in all, we have a collector space of 11,000 square meter. But in this case, we had 2 depth layers. So the first installation depth was 1.50 meter and the second was 2.9 meters. So all in all, we have a collector space of 22,000 square meter. And we have a 6 kilometer district heating and cooling net feeding 400 apartments. And you know, the collector system and the district heating and cooling network has the same temperature level. So this district heating and cooling net acts also as a collector. And our goal is to monitor the groundwater and the soil temperature in this project. Here you see also the project partners, just to give you an idea of the size. Another goal is that we have to identify the relevant petrological data sets for these new collector-based low temperature heating district and cooling networks, and we should provide some petrological parameters for the simulation, because we want to develop the simulation tool for these applications. Okay, here you see some impressions of the installation process. As I said before, this is very fast. I think all in all, it was 2 weeks to install the complete collector system. And yeah, as I said before, also for the requirements, it was relatively easy to install these systems. Okay, so at the end, as I said before, I want to give you an outlook of a planning tool, which you can also calculate potentials for these collector systems, and also, as I said before, for the 5th generation network, because it's the same installation depth and act also with the same temperature level. This tool was developed under the umbrella of the Thermomap project. This was a European project. I think this was 7 or 8 years ago. But also Eject was involved due to the fact that they were the dissemination manager. And here you see the new link, because I think this was 3 years ago. We had some problems with intellectual property rights. Now the new map viewer is OpenStreetMap based, and yeah, some companies gave us 50,000 euros to make this update, because they want to use this as a planning tool. And yeah, here you see the link, so you can use this also for your planning for the first step. when you go more in detail, you have to you need better data sets. So from my side, thank you very much. There's also a research and a small medium enterprise network dealing with these issues called Soil to Heat, which you see here at the top of the slide. At the moment, it's only between Germany and Austria, but we are planning to make it more international. So when you enter the website, I'm sorry, but it's only available in Germany at the moment. So thank you very much.
Thank you very much, David, for this interesting topic and presentation. I would like to encourage the audience to write their questions into the question section. And I have a question for you, David. So you have like a double layered collector, and how do you calculate the energy which is brought in the system? Because the upper collector gets heat from the sun or from rain and so on. But how do you calculate the lower collector?
Yeah, we simulate this with two different simulation softwares, and you can also play with the two layers, because one layer has a lower temperature, and you can use this for the summer for cooling the houses, and then you can recharge the upper layer, for example. So this is the idea, that you can play also with the two different layers and the two different temperature levels. Yeah.
Okay, so it's for heating and cooling at the same time.
Yes,
also.
yes, it's also for cooling, yeah, in the summer.
Do you also calculate like the case that the volume between the two collectors freezes?
Yes, also from the municipality who planned this was as a goal that you say, okay, we have to look at the different levels, also from when all 400 houses are using this source. We have to check if there are some critical parts or some critical month where we had to look for freezing or yeah.
Okay, so we have a few questions coming in. What was the peak thermal capacity or also cooling peak capacity of the large horizontal double layer system that you described?
So all in all, it was planned to have 1.1 megawatt heat load. Yeah. Okay. But if you want, I can also provide you more detailed information about the project or about the parameters. It's also not a problem.
Yeah, so I will get the contact to you from Robin Curtis.
Yes.
Is the system in Bad Nauheim reheating the ground in some way, and how is the ground energy balanced?
At the moment, we have the simulations shows that you have that the conditions for the soil are not affected the farmland, because or the attraction of the farmland. But as I said before, this is installed, I think, 3 months ago, and now we have the first winter in the monitoring, so we will see.
Okay. There was another question. What modeling tool do you use to assess the environmental impact of the systems on temperature and groundwater, where you use open loop or lake or sea?
Yeah, we use two different systems, or we use COMSOL for the collector systems, and we use for the impact of the environmental things, FeeFlow. and then we combine these two things. So this is the challenge at the moment. Okay.
Thank you very much for answering the questions. The other ones will be answered directly. Thank you very much. We will go on, and Javier will give us an insight in the updates on technologies in geothermal cooling, heat pump materials, and drilling. Thank you for being here, and the stage is Javier's.
Hello, good morning. Do you see my screen? Do you see my screen?
Yes, thank you.
Okay, good morning to all of you. My name is Javier Ochoguía. I belong to the Universidad Politécnica de Valencia, and I'm related to some activities in the area of innovation in Europe, with the chairman, being chairman of the geothermal panel, and being involved in many also activities in the area of research. And I want to talk today about two aspects of the innovation in the geothermal sector, which is related to the cooling question, the importance of cooling, and also with other aspects which are critical, such as the heat pumps, the question of drilling, and also the materials. So I want to go on with my presentation, talking about the cooling as a key differentiating factor for shallow geothermal systems towards or in comparison with other technologies which do not so easily provide cooling. So in fact, there is not so much, let's say, alternative nowadays to a heat pump providing cooling in terms of renewable energy. Also, there is much more awareness and legislation coming up. I will talk about this later. So I think it's a very important aspect to take into account, and cooling could be a really key driver of the future deployment of shallow geothermal energy. The second question here that I would like to discuss is, it's still important, as it was in the past, for our strategic position to reduce costs, because costs are also one of the factors that affect marketability of our technology. So I will talk in the second part of the meeting about several activities, several initiatives, projects that are going on or have recently ended, dealing with the question of cost and what were the results, what is going on in the area of the cost reduction in geothermal systems. So in the question of cooling, I will comment three aspects which are important. I will talk about what are the different technologies in the cooling area. I would also like to comment this question about the current legislative trends in cooling, which is, I think, very important to take into account. And later comment briefly some case studies in very specifically dealing with cooling. So first of all, about the technologies. So traditionally, we have been in our minds the idea of that cooling is direct cooling. That means it was identified with the idea that the underground, the free cooling of the underground, linked to the existence of some resource, underground resource, which is cooled, which is on a low temperature, as you can see here, with this scheme of an installation which provides the so-called geocooling. So this concept is more linked to the idea of energy storage. And here you can see, for instance, a French piece of legislation about this geocooling concept, RT 2012. It's from 2017, and it shows how complex and detailed the methodology must be to really take into account to manage this type of resource. So the idea is that you need, from the point of view of the EU, a much more simple frame, because this type of concept is difficult to scale, and it's difficult to apply in other conditions, like countries where this type of resource is just not available. The example would be Spain, in which direct cooling from the underground is just unthinkable. It cannot be used. So there are, fortunately, other options for renewable cooling through geothermal, which is, apart from direct cooling, we have the indirect cooling option, which just means to use a reversible heat pump, either from the ambient or hydrothermal or geothermal. And with this reversibility of the heat pump, we can provide cooling and heating mechanically. And then we have the third option, which is only suitable for larger systems nowadays, which is to use sorption or absorption technologies to the direct conversions of heat into cool. And this heat could come, for instance, from either waste, or also, as we can see, we will see an example right now, from geothermal heat. So I think these are the three areas of cooling where geothermal cooling could be important. And we have to depart from this narrow perspective of only talking about direct cooling when we really want to scale up our technology in the area of cooling. So I would just to provide you with an example here from France, from the University of Paris-Saclay, in which you can see a very complex system, which is where the heat is coming from a geothermal electricity production central, or you can see here, and then this is feeding some sub rings where you can through absorption chillers produce with these four tube systems heating and cooling for the buildings of this Paris University. So this complex net called Saclay is currently under development and operation partly, and I will show you the link so that you can see more details about how this system is set up. So you can cool also from heat, as you can see here, from geothermal heat, or heat from like here from combined heat and power, because also this station is releasing heat as a consequence of the production of electricity, and also from waste heat. So there are, as you can see, other cooling options, and this one is an exciting system, complex system network, providing all electricity, cooling, heating. And you can see that this concept is not standalone in Europe. Here we have I show the number of geothermal heating and cooling plants in operation with this type of concept in Europe. And as you can see, the good news is that there is no country in Europe which has at least a plan to develop in the near future, or which is investigating this resource. You can see also that there is a rather heterogeneous landscape. There are countries with many, like France here, you can see, with many such plants, and many countries with just a few. So this shows again how important the learning curve is. So you have to gain knowledge, you get to have confidence in the technology to be able to deploy it. And as more plants are there, there are more plants will be developed in the future. So it's very important to start, to get confidence in the technology, and to start, let's say, constructing these systems. From the very broad perspective of cooling, how does the landscape look like? In the direct cooling arena, you can see snow, sea, rivers, lake. So there's really a niche market. I would like to accept here the Atheist technology, which will be shown by Bas in the next presentation, with Aquifers, and which is rather experimenting and growth in the Netherlands, also in Germany and Norway. In the area of indirect cooling with geothermal heat pumps, unfortunately, we are seeing not let's say a steady growth in the market with around 100,000 units per year in terms of sales in Europe. Although it must be said that the current trend is to have larger and larger units. So probably the capacity installation is growing, but the number of units is more or less stagnating since some years ago. So it is important also from the legal perspective to tackle this question of the cooling. Here also we can see this cooling with rest heat, and the market is just emerging, as we have seen. Although there are different examples in which this concept of cooling is really powerfully shown, like in this Paris University. So we expect to have more and more systems of this type in the future. Here also, what would be needed to let's say accelerate all this deployment. So again, as I talked before, we have to be very. It was commented by Thomas Novak last Tuesday how important the efficiency is. Indeed, nowadays we have seen in different markets that the threshold for a system to be, let's say, cost competitive against gas is decreasing in terms of SPF. That means that electricity is always more expensive than gas, but this difference between the cost can be, let's say, can be tackled by the larger efficiency of the system, and this threshold is varying from country to country, because also the taxation and the cost of electricity is different. So there are countries nowadays in which the current SPFs of geothermal systems would overperform the cost of gas in the real markets, but whereas there are other countries in which SPF has to be much larger than today to overcome this difference. So efficiency, or the increase in efficiency, has to be a mantra for us. We have to pursue as much efficiency as possible within the technological possibilities of the geothermal systems. And the other big area for improvement would be the improvement and the, let's say, scalability of the absorption cooling systems for these future networks that I have shown before. In terms of different, let's say, examples, a question I would also like to comment a little bit now is the question of the legal frame. So we are seeing, and I will comment in a brief slide how this looks like nowadays. The question of cooling is also, from the legal perspective, being tackled now by the Commission with new regulations. With even there is indeed a draft of a new regulation for talking about the question, or defining the question of renewable cooling. So this is very critical, and I will comment in the next slide about this new evolution. Here you can see some flavor, some insight about this new regulation or new methodology for calculation, which we hope really sets up the question of what is renewable cooling, which is, from the thermodynamic point of view, a rather complex question. So from this regulation, cooling is defined as free cooling, or cooling with a minimum efficiency requirement. If we would just talk about free cooling, we would be just in this first basket of possibility, which would leave us without most of the market, really. But what is the minimum efficiency requirement to talk about rest cooling? So this is given according to this new formulation by a formula, which I will describe a little bit briefly here, in which we calculate this renewable cooling contribution, which is in the left of the formula, by means of this concept of the heat amount by the source, which is the amount released by the source to the ambient, the energy input, and this difference, which would be the cooling supplied by to the building in this case, or to the appliance. This cooling supplied by the appliance will be multiplied by a factor, this SPF factor, which is a number, is a percentage, which describes or defines the level, the share of the cooling supply that can be considered as renewable according to this SPF methodology. So it's a percentage between 0 and 100%, which let's say caps this produced cooling and gives you the amount of renewable cooling given by your appliance, by your system. How this SPF factor is calculated is very important, and the formula is the one you can see here. So this percentage is a percentage which measures the SPF of your individual, your particular installation, which is this number here, SPF-P, in comparison with an installation with the highest possible SPF considered by the methodology, which is 9.5. So within the maximum and the minimum, which is 1.4, your appliance, if for instance 5, would have the given percentage, the given share for this renewable cooling contribution. So this means that this formula, this methodology, would consider renewable cooling those installations which provide the maximum efficiency. If you are 9.5, you would be at 100%. If you are 1.4, you would be at 0%. And all what is in between would mean that the corresponding share of renewable cooling. This sets at least a frame to define from the methodology and the legislative point of view this renewable cooling and how this could be incentivized in Europe through the different legislations and frameworks for promotion of renewable energy, which is very, very important. Just to end up with the cooling question, just to show you some examples and some here with with information from different projects or different initiatives, which you could look more detailed. For instance, for the indirect cooling technology, there was an old project, Geocool, which was many years ago, in which a system was operated to show what would be the potential efficiency of a cooling or indirect cooling system compared to other technologies. I will show some brief results in the next slide. Then you have these other very interesting sources of information about the systems I was talking before, like this Paris suburban area, which is quite interesting to look at. Just to go very briefly on these Geocool results, this was the scheme of this application. This was described in an old paper in 2008 here, which you can see all the details on how this system was operated. And the main idea was to compare a conventional state-of-the-art air-to-water heat pump with a water-to-water heat pump run by geothermal. So you can see here the main scheme. And what was the result? It was run 13 years. During 13 years, this installation was running and was collecting many data in the subsoil, measuring the temperature in the ground, measuring the different flows of energy, and also comparing the energy requirement, the energy input into the installation here. And it was running very satisfactorily during this time as an experimental unit to assess all these questions. It was also used for heating, as you can see in this graph. And this is the very, let's say, summarized example of a performance of a given year. This was one of the first years in which you can see how different, how larger the performance factor of the cooling and heating of the system is when you use geothermal instead of aerothermal. Even in cooling, the difference between the air thermal and geothermal part is even larger. It was more than 60% improved in performance compared with the aerothermal. And I must insist, this air-to-water heat pump was a modern state-of-the-art heat pump. So the geothermal source gives us really the possibility of going to much higher efficiency. And in view of these legislative methodological improvements you have seen before, it could be a very, very important question for the market deployment of geothermal technologies. So just to end my presentation with some of the aspects I promised to also tackle here: heat pumps, drilling, and materials. I just briefly wanted to comment some very new results from different European projects that were running in the last years or even are running nowadays. One of these, it's CHIPS, ground source heat pump project. I have put here the websites, which you can easily see some much more information that I can tackle here in this presentation. And here in the case of the CHIPS geothermal project, I would really encourage you to look at the training manual, which is a very large account of all the innovations and all the results that were obtained in this project. One of the, for me, most important one was this decision tool. The CHIPS was specifically oriented towards the decrease in first cost of such geothermal installations. So there was a development of a tool, a decision tool, in which there are maps in which you can see comparing different technologies, drilling technologies, for instance, what is the cost in terms of euro per meters, and what is the most cost-efficient technologies you can use in a given area, in a given geological condition. The other very important technology which was developed in this project was this Hydra red drilling technologies based on vibrational method for drilling and a pre-outformed coaxial heat exchanger concept that accelerates a lot the installation of a ground heat exchanger up to 100 meters. So I think this was also a very exciting development and shows how much you can improve drilling time, drilling cost by improving the technology and automatizing the process. A third very interesting area was the heat pump. The CO2-based heat pumps is an option to obtain higher temperatures, leading to heat pumps that can substitute a boiler without the need to renew all the internal distribution system of the building. This is also a terrific possibility and needs a new type of heat pump that is based on CO2 or maybe other possible technologies, which was produced by Galetti and tested extensively in the Zagreb Museum during more than 1 year to assess its performance in heating and in cooling with very nice results. So we hope to see this type of products in the market soon, and which may really improve the conditions for geothermal projects. Other important, let's say, developments were in this GeoCon project, which I coordinated up to this last May, with a very nice breakthrough in pipe technology. You know, perhaps that pipes are, plastic pipes have a quite low conductivity, and there has not been in the market a suitable pipe for geothermal, which are higher conductivity than the current ones. We have developed in GeoCon a new pipe, which runs up to depending on the exact composition, 1.2 watts per meter Kelvin for geothermal applications, which also is able to outstand all the mechanical and other conditions for the installation, and it's from the point of view of installation similar or equal to the existing P100 pipes. So this was a development of GeoCon, and we hope to have all this product in the markets also soon. And this leads to a reduction of the RB, which in turn allows you to reduce the number of meters to install from 10 to 40%, depending on the concrete geological context and the application. Also, in GeoCon, other products like new grout formulations were developed with a stable possibility to mix with PCMs, for instance, for applications such as PCM. And last but not least, just to mention that all these products were tested at a large scale in real scale applications. There were several borehole heat exchanger of more than 100 meters constructed and done with this technology. And my last slide to end, just to mention very briefly a new project which is now going on, which is focused on all these questions, but which pursues the further improvement in terms of effective integrations of these geothermal products into existing buildings. There are improvements in this rotation vibration technologies for drilling heads, more automatization in the feeder technologies, which allow a very high speed, also in difficult ground, which in cheap were not possible to tackle. And finally, more new heat pump concepts are being developed in GeoForCivic, including two-stage compressions and the possibility of use new mixtures of low GWP gases that let's say do not harm the ozone layer. So thank you very much for your attention, and I'm open for any question you would like to make.
Thank you very much, Javier. We have time for a short question until we go further on. So what do you think, how can cooling with geothermal be made more attractive to Mediterranean countries, especially islands?
I would say that otherwise, for Mediterranean countries, if you do not include cooling in your package, it's not attractive at all. So cooling must be, let's say, a must in a geothermal installation. And indeed, most of heat pumps installed in Mediterranean area are heating and cooling heat pumps. So it is very important. And the way to make it more attractive is to decrease installation costs, first of all, and to also make efficiency as large as possible in order to, let's say, so that the gas option is more expensive than the electricity option. And in Mediterranean area, because of the legislation, you are forced to have a solar panel to provide heating. Okay, so if you could have a 3-in-1 solution with a geothermal heat pump, which you can provide heating, cooling, and also hot water, it is very attractive. But as I said, you have to decrease cost and you have to make it more efficient.
Thank you very much for the explanation. We will go on with the next presentation by Ignacy Herms about the progress in the development of shallow geothermal energy market in Catalonia.
Okay, thank you. Just to share my screen, can you indicate me, please? Okay. Can you see my screen?
Yes, it's all perfect.
Okay, so hi everyone. Thank you very much for inviting me to this new edition of the European Shallow Geothermal Days. My name is Ignatius, and I'm the head of the Geological Resources Department of the Cartographic and Geological Institute of Catalonia. Just for those that don't know, our institute, ICDC, is a public entity dependent of the autonomous government of Catalonia that include the functions of the Geological Survey of Catalonia. Our activities are, among many others, to develop and promote works, studies, and assessments in the field of geology and related disciplines, including geothermal energy, and advise and provide technical assistance to other departments and administrations. So I have structured the presentations in two blocks. In the first part, I will present an overview of how the market of shallow geothermal energy in Catalonia is progressing according to our vision. And then I will comment some of the activities that we are carrying out at the ICDC in order to promote this technology. If we talk about the beginnings of the shallow geothermal energy in Catalonia, this began to be implemented in the early 2000s with some experimental and demonstration projects. It was in 2002 the first specific company dedicated to shallow geothermal energy was created, which was the one that implemented most of the facilities promoted in the first decade. From then on, other newly created companies appeared in Catalonia, or others that began to include geothermal heat pumps in their catalog of service. Also from the years 2008 and 2012, the first medium and large facilities of the tertiary sector were implemented, which have been a reference for many subsequent installations, although smaller, such as the installations of the Hospital Sant Pau Modernist complex, located in the city center of Barcelona with almost 3.6 megawatts of thermal energy, which is the largest closed loop systems we have in Catalonia. Then from 2008, shallow geothermal energy in Catalonia began to grow with more push when large projects such as those I have commented before began to be considered. In that moment, the industrial sector considered necessary to join all together under the umbrella of a cluster of companies to promote technology more strongly. And it was in, in that moment between 2010 and 2011 that in Galicia, a region located in the northwest part of Spain, appeared its geothermal cluster. Meanwhile, in Catalonia territory, the companies tried to do the same, and between 2011 and 2012, also tried to create the geothermal cluster of Catalonia. However, the initiative didn't progress, and in the end of 2012, it was abandoned mainly due to the economic crisis. Then from 2014, the ICDC, in collaboration with the Professional Association of Geologists, continues to carry out dissemination and promotion actions with, for example, two face-to-face conferences held in 2015 and in 2016 with more than 200 registered people each. And the success of this event was a catalyst for deciding to look for the integration of the geothermal sector under the umbrella of a cluster. And it was then when appeared the opportunity to do that with the cluster of efficient energy of Catalonia. This cluster was seen as a perfect framework for inclusion as it was already consolidated and because it had, among other pillars, let's say, the energy efficiency of buildings, electrical renewables, and domestic self-consumption, which links perfectly when we think in hybridization with ground source heat pumps. So in January 1st, in 2019, the new geothermal working group within the cluster of energy of Catalonia was officially created. Here you can see the picture of the preparatory meeting held in the ICDC headquarters in Barcelona in 2018. Of the total of more than 170 members of the cluster at present, a total of about 50 are part of the geothermal working groups. such as installers, consultants, and engineering companies, drillers, heat pump suppliers, and some governmental agencies and local administrations, and so on. So in that moment, one of the issues we wanted to address was the low visibility that shallow geothermal energy had in the market. Catalonia has no specific detailed legal framework for shallow geothermal energy systems, and a direct consequence is that there is no official record, and therefore there were no official statistics on the state of the implementation of the shallow geothermal energy. But in the other hand, the ICG considered that this information crucial to guide, for example, its products and services. And therefore, the 2019, the ICG created what we call the Geothermal Observatory. It's not an official register, but an inventory of collected information with the aim of having an up-to-date picture of the geothermal exchange systems that are in operation or in project, with the aim to see how the market is progressing. The information comes mostly from companies in the cluster itself. The objective is not to control the installation, but contributing to make shallow geothermal energy more visible. The elaborated information is updated every 6 months by publishing a report with statistics, with interactive and dynamic tables for online consultation and maps in a GIS viewer. In addition, we produce and deliver fact sheets in PDF with the basic information we collect of the installation promoted by public sector. But from the information collected so far, we can conclude that, for example, Catalonia is growing. The market in Catalonia is growing at 20% per year, according to the last report. This number fits the number of 20% attributed to Spain, based on the last, based on the IGEC 2019 market report. Also comment that 20% of the installation are promoted by public entities and the rest for the public sector. But apart from the ICG, the cluster also are publishing in their website what they call demos fact sheets. This corresponds to examples of successful cases of shallow geothermal installations located throughout the territory of Catalonia, in which some of the different members of the group have participated. Part of the classical installation in the domestic sector, if we look at the type of installations that are operating in Catalonia in public facilities, for example, we will see installation in town halls, buildings, sport facilities, museums, some universities, public kindergartens, fire stations buildings, offices buildings, and so on. And on the other hand, if we look at some of the reference installations in Catalonia carried out so far, we must mention, for example, the district heating and cooling hybrid network with shallow geothermal energy, hybridized with biomass and solar photovoltaic in the municipality of Olot in the north of Catalonia, the buildings of the sanctuary and the public hostel in the valley of Núria, located above 2,000 meters of altitude, that began its implementation in 2011, and will end with more than 1 megawatt of installed capacity, and other kind of buildings of in Barcelona, for example. However, the penetration of geothermal energy in Catalonia, from our point of view, has several difficulties. For example, within the energy transition process, the public media are now essentially focusing the strategy on the power generation with solar photovoltaic and wind farms, including self-consumption with photovoltaic and promoting local energy consumption communities with photovoltaic. But it's difficult to get out the debate and talk about shallow geothermal energy. But if we talk about thermal energy, the focus also has been until now mainly to use and promote biomass. If we look at urban areas, although biomass is also being implemented in general terms, the debate is about the electrification of demand, which is when indirectly we can think in the use of the heat pump technology in the broad sense. But it's really very difficult to hear something explicitly about shallow geothermal energy in the energy agencies. So there is other difficulties like some barriers. We have no any clear legal process to get the permits, and we have had a previous bad experience of shallow geothermal installations, not directly related to the ground and environment impact, but also more related to the electrification of the room and so on. But we are also optimistic to see some signs that make us think that the market will grow in this decade. For instance, the perceptions of climate change affects the progressive increase in the annual average temperature year by year in Catalonia, and the need for eliminating fossil fuels in heating and cooling sector. So this is positive. Nowadays, more than 54% of the energy consumption in the domestic sector burns fossil fuels. On the other hand, the recognition of geothermal energy as a technology that can play a crucial role in the decarbonization of thermal demand, thanks to the fitting into the electrification strategy, is starting. Also comment that 2 decades of a slow growth rate, now ground source heat pump sales has been experiencing a strong increase, and now the growth rate estimated is almost 20%. Also, finally, we will have in brief. Now we have right now some interesting grants and subsidies that I suppose that will increase the sales of ground source heat pumps. From the ICGC, we are working to raise awareness of the available resources we have in our territory by generating information and tools to help implement the energy sources. Regarding shallow geothermal energy, we are working to generate information either at regional scale and local scale. At regional scale, the ICGC develops and publishes throughout online GIS viewer thematic maps of useful information. And this is a live project that are continuously updated, adding new datasets. In this slide, you can see a sample of the different thematic layers that we have already published in this moment. Among them, for example, maps of the heating degree days or cooling degree days, length of the heating and cooling season, subsoil temperature estimated at different depths, thermal properties, and so on. And also a map of the shallow geothermal potential for closed loop systems using the well-known GPOT method, a method developed by Casasso and Setti in 2016. But as I said, we still are in the way to produce other kind of maps to disseminate, for instance, the suitability for open loop systems. ICGC activities, as I said before, it's also focusing at local scale. The main recent example has been the participation into the Joera Muse project, which is a pilot case study located in the urban area of Girona and situated in the northwest of Catalonia. I want to mention that beyond the result of that project, the implementation of itself has served to start opening the interest of some municipalities for geothermal energy, a part of Girona obviously, which was not there before, and in this sense is already a success. The other project at urban scale we initiate in 2019 is the implementation of monitoring networks, in which we install temperature and groundwater level sensor coupled with telemetry systems. In any case, the implementation of monitoring networks has 3 important aspects for us. It generates data to have the assessment of potential at the city level. It offers an open and permanent web service to the city with fair data useful to manage the ground. And finally, it raises interest and awareness of the shallow geothermal energy among the decision makers of the municipalities. The ICGC also aims to encourage administrations to promote real projects that can be considered demonstrative and at the same time arouse the interest of other administrations. One of them is the called BA Smart Multi-Res Micro District Heating Grid project, which is promoted by the autonomous government of Aran Balait, located in the northwest part of Catalonia, inside the Pyrenees Mountains. This will be a new micro district heating grid hybridized with shallow geothermal energy, biomass, and solar photovoltaic. ICGC will perform the geological studies and support the engineering work needed to promote the project. But on the other hand, we see, at least in Catalonia, that the main barrier in trying to explain and convince people, stakeholders, in the goodness of shallow geothermal technology is always the discussion of the economic issues. I mean, the cost of the investment and payback compared to other sources, renewables or not. What we have experienced is that when we are just talking about geological issues, the debate is usually over because decision makers and users are not really listening to you. Therefore, in our case, and at least in our territory, we think that we cannot dissociate the geological from the technological and economical part. And in this discourse, and this is why one of the reasons why we have decided, in collaboration with the Polytechnic University of Catalonia, to design and publish a new tool to help carry out pre-assessment of shallow geothermal systems in closed loops in the territory of Catalonia using the GIS dataset elaborated and published by us. The new tool was released 3 weeks ago and is called GeoZip. It's a standalone software that can be downloaded for free from our website. As I said, this GeoZip app allows preliminary assessments of geothermal exchange systems in closed vertical circuits up to 70 kilowatts, which corresponds to the type A and B in accordance with the Spanish standard UN guide for the design, implementation, and monitoring of geothermal vertical closed-loop systems. In these first versions of this app, the users can introduce or make a first rough estimation of the thermal loads and demands of buildings, calculate the borehole heat exchangers field arrays, and introduce or choose from a small database a ground source heat pump. The tool has an economic and environmental analysis model that allows to compare the project solution based on shallow geothermal energy with respect to other energy source, which can be biomass, aerothermal, solar thermal, natural gas, diesel, LPG, etc., and calculate the payback, net present value, the internal rate of return of the investment, and the CO2 savings. I would say that the main point of the tool is that allows to consider photovoltaic hybridization and the use of batteries also. And from the ICDC, we carry out also dissemination actions in the field of geothermal energy. For example, preparing informative fact sheets, which then we use to show the wide spectrum of ground source heat pump technologies that exist and can be adapted both in large areas as well as in rural and mountain areas. And I think that this is useful. It's a very useful tools either for decision makers and general public. And finally, just to finalize, it's also worth mentioning that in ICDC, in collaboration with a cluster of the efficient energy in Catalonia, organize an annual event called GeoEnergy. This year we have celebrated the 3rd edition in a hybrid format with more than 200 people attending both virtual and live. The first edition in 2019, the focus was dedicated to the hybridization of photovoltaic solar energy with ground source heat pump. The second edition that was held virtually focused on geothermal energy in the broad sense in cities. And in this year, the focus has been the role of shallow geothermal energy in the energy transition process. We think that these events, if it can be done face-to-face, are very interesting because they are an opportunity for promoting networking between installers, engineers, and end users. And it's a way to involve decision makers so that they participate and learn more about this technology, a part that allow us to appear in the media, obviously. And that is all that I wanted to present from my side. Thank you very much for all. Thank you.
Thanks a lot, Ignacy, for this very interesting view on the shallow geothermal energy market in Catalonia. At the moment, we don't have questions from the audience. I think when they will come in, you will answer them in the chat directly. So thank you very much. And we will go on with our last presentation for the day from Bas Gottschalk about open loop systems and ATIS and which potential they have. Welcome, Bas.
Thank you very much, Constance. I expect that everyone is looking forward for his or her lunch, but I hope to feed you a little bit with my presentation. I've changed my title to Breakthroughs in Shallow Geothermal Technologies in the Netherlands, because I first would like to tell you a little bit more about the actual situation of the use of shallow geothermal energy in the Netherlands, and also the new developments and a new technology, which is, in our point of view, very promising technology in the energy transition where we are. So let me introduce myself briefly. I'm Bas Godschalk. I'm the business developer of the high temperature storage technologies and the international project at Atheist Technology, and I'm working here already for 14 years. And our company, Atheist Technology, is a consulting and engineering company in all types of shallow and deep geothermal energy systems. And with 90 specialists in all fields, we are capable to work on many projects. And since we are founded 30 years ago, we have worked on more than 3,000 geothermal projects. So what's the status at the moment in the Netherlands? What we see is that in this figure is presented the amount of energy which is harvested from the geothermal systems. So you see the yellow line, which is the deep geothermal energy heat which is harvested. You see there's a rapid increase during the last years. Oh, I'm sorry. No, oh, there's going. Now I only see myself, sorry. So, and the shallow geothermal energy, it's still developing, and you see that there is a difference in the amount of heat and the amount of cold which is needed. But as Javier also mentioned, cold is a very important business driver during the last years, but we see that there is an upcoming market for heat demand. During the last years, about 3,000 Atheist systems has been developed. Let me tell a little bit more about the Atheist technology, which is the abbreviation of Aquifer Thermal Energy Storage System, which is in base a battery system where you store the seasonal heat in the warm well and the seasonal cold during the winter you store it in the cold well. And then in the next season, you can reuse the heat or the cold to heat or cool your building. Now, typical ranges of the cold well are in the Netherlands 5 to 10 degrees, and of the warm well 13 to 70 degrees. And you can imagine that 17 degrees is not enough for direct heating, so you need a heat pump to increase the temperature levels. But 5 to 10 degrees is a perfect temperature for free cooling, for direct cooling of the building. Now, typical depths of the wells are between 40 and 250 meters. And when we speak about this technology, we often work on projects which has flow rates between roughly 25 to 250 cubes per hour. So that are large, bigger systems which can fulfill the complete energy demand of buildings. Now, when we look where this system has been applied, then you see that the big market is the utility market. Many offices in the Netherlands do have an Atheist system, but also hospitals and university campuses, in greenhouses, airports, data centers, shopping malls, and upcoming are the residential areas. So that's roughly where you can find this application in the Netherlands. When you look at the development during the years, you see that from the 90s, there is a rapid increase in the amount of systems. And the question is, when we look around in other parts of the world, we see that there are many systems of this large-scale Atheist system in the Netherlands, and we know that in Sweden, that is number 2. They also have many systems, but then in other countries, you see that the amount of system is still a couple of, but not thousands, which are probably needed also in the energy transition. So the big question is, why not? Why is it successful in the Netherlands? Now, we think there are a couple of reasons. One of these reasons is that we have very good aquifers, and that's a big advantage because for this technology, you need aquifers where you can abstract and inject the groundwater to exchange the heat, the cold, and to create a cold well and a warm well. So in our situation, to nearly each client, we can say it's no problem, we can work on an ITES project for you. And that is very encouraging the introduction and the implementation of this technology. So yeah, we know that in other countries the situation could be different, but it helps us in our country. Another thing which is important is what I mentioned is that you need, that you have to use it as a battery. So you need a cold season and you need a warm season. And so the climate conditions are also important. And when you have only a very warm climate, it's more difficult to charge the battery with enough cold to be able to provide the cold during the summer season. And another point which was also mentioned already in one of the other presentations is the importance of the legal framework, because if there's a lack in a good legal framework, it's very hard to apply shallow geothermal energy. So when there is a framework, you know how to ask for a permit, and you also know what are the conditions for a permit. And this really helps to be able to work on permits for your clients and to give them a guarantee that they can use these systems for many, many years. What we see at the moment as trends in the shallow geothermal business. In 2018, the Netherlands decided to get rid of the gas. So all new types of energy concepts for residential area, but also for offices and other buildings, is that gas is not allowed anymore. So you should look for alternatives. And that really encouraged the development of the shallow geothermal market. We see that in the past, residential areas were not very interesting for shallow geothermal energy. Why not? Because shallow geothermal energy is a very good technology to provide very low cost cooling. So in buildings where cooling was required, we had a very good business case. But in residential area in the Netherlands, it's not really necessary to have cooling, so it's not applied. So the business case was not working very well. And we had cheap gas, so why should we do so complex? So at the moment, we see no gas is allowed, and geothermal energy is needed also for the residential areas. It's a mature business, and we see that more and more turnkey companies can take over and just realize systems. And that also helps to reduce the cost, which was also mentioned as an important factor during one of the other presentations. And we see a growing interest in district heating network. So we hope to learn from other countries how they implemented this kind of networks. And we also see that there's a growing business to optimize the use of heat, which is produced by geothermal wells or biomass or rest or industrial waste heat. So this resulted in 3 technical developments. Let me go through them briefly. One of the developments is that from standalone solutions, so one ATES system for one building, we start to think how to make a district heating and cooling grid where more buildings can be connected to one grid and where the wells are not connected to a building but are connected to a grid, which makes it more efficient in total because you can also exchange heat and cold between the buildings. But you can also have a better use of the amount of systems, and it's for the spatial planning, it's more easier to plan the ATES system wells. So this is a very important trend. And the second trend is that we are more and more making use of surface water energy, because for especially the residential areas, we see there is a big heat demand. But for an ATES system, you need to charge the battery with heat. So what we do is that we use the high temperatures during the summer of surface water, like rivers and lakes, to charge the Atheist system with enough heat. And then during the winter, we can reuse the stored heat as an energy source for the residential areas. Now, this is really an upcoming technology, and now we have already made more than 50 systems, and it's becoming bigger and bigger. And the last interesting technology I want to highlight is the high temperature storage technology, high temperature Hydras. We call it high temperature, but we have to distinguish between the middle temperature range, which varies a little bit from 40 to 60, and high temperature from temperatures up to 90-95 degrees. It's a typical buffer, so you charge the wells with high temperatures, and then you can reuse it as it is presented in this schematic. Why should we use this high temperature storage technology? When we look, for example, at deep geothermal wells, they are capable to produce heat all the year round. But during the summertime, the demand for heat is relatively small, but the system is capable to still produce heat. And we know from a technical point of view that it will be better to keep these geothermal systems in operation, and the heat which has been produced could be used during the winter time if you can store it temporarily. So what we do is that we store the surplus of heat which is produced during the summertime in the high temperature storage system, and then reuse it during the winter as an extra heat source. When we look at the sources and uses, then we can see that typical sources for this technology are deep geothermal wells, which can produce 70 up to 100 degrees in this northern region. We see that more and more companies are asking us to support by storing heat which has been produced by solar collectors. There's an idea to store the heat of waste heat, industrial heat. Power to heat is a new demand where they want to produce hydrogen, and then the rest heat can be stored in this high temperature storage technology. Typical uses is that you connect the storage system to district heating systems, and greenhouses are up to this moment the biggest client, but it can also be used for feeding the networks for residential areas. One interesting thing is that during the last years, we have worked on a full-scale high-temperature storage project in the northern part of the Netherlands. In the middle picture, you can see the network. There are a couple of deep geothermal wells which are feeding a high-temperature heating network. And then at one of the greenhouses, pepper breeder, they need a lot of heat. So the idea is that from the deep geothermal wells, the high temperature storage system will be charged during the summertime, and then during winter time you have extra capacity because you can provide heat from the wells and you can provide heat from the geothermal system. Now, what we did in the beginning is first to start to make a test drilling, and the test drilling given a lot of information of the buildup of the soil, the different layers. So you see a schematic on the right side where the yellow parts are the yellow and green are the aquifers, and then the gray layers are the clay layers. So in this specific case, we have chosen to use the fourth aquifer, which is the very yellow line, and then we drilled the cold well and the warm well. and we also installed in the same borehole monitoring screens, which makes it possible for us to perform a lot of monitoring during the exploitation of this project. And also we installed a fiber optic cable in all the 3 wells, which makes it very easy to monitor the temperature development in the wells. On the left side, you see some parameters of this system. It has a heating capacity of about 10 to 12 megawatts. And the maximum abstraction and injection flow rate in this system is 150 cubes per hour. And the injection temperature of heat is about 85 degrees, and we can cool down the abstracted water till 35 degrees, and that will be re-injected in the cold well. Now, some pictures of the installation. On the left side, you see the drilling rig, which was busy to make one of the wells. And in the middle picture, you see the well head, where on the left side you see the piping, which goes till 380 meter depths. And then you see a quite complex well head with a lot of equipment to be capable to abstract and inject 150 cubes per hour at the temperature of 85 degrees. And on the right side, you see the technical room where big heat exchangers are installed to provide the heat to the greenhouse. Now, what do we expect during for the next period? We think that high temperature ATES is a great solution as a heat buffer. Because you can store at high temperatures, which can be directly used by greenhouses or by residential areas. That fits very well with district heating systems. I'm not sure if you have to work with the 4th or the 5th generation heatworks, but I think it will be 4th. You see that the heat demand in Europe is high, and in the Netherlands it's expected that about 100 to 200 high temperature storage systems could be realized, and especially in combination with deep geothermal wells, and also other industrial heat sources could help to make it successful. And other calculations counted up to 2,000 high temperature storage systems in Europe. So we believe and we know that geothermal technologies are more and more essential for our energy transition. And that's my presentation. Thank you very much for your attention.
Thank you very much, Bas, for this very interesting presentation. So we have a few questions. How do you handle environmental issues when infiltrating surface water to groundwater aquifers?
A very good question. We have good negotiation with the authorities to show them what are the expected impacts. We have a demonstration project which has been realized a couple of years ago, which gives us a lot of input about the development of the geochemistry of the water, the microbiology, and physical impacts of this high temperature storage. And we have performed some modeling to demonstrate what are the real impacts on the aquifers and environment. And then together we decided that the risks are relatively low so that it is allowed to perform the system. But at the moment we are also doing a lot of monitoring to verify if all the starting points and assumptions are true. And this is also done within the international heat store and warming up programs. And that should also give us a lot of information to prove what are the best ways how to operate such a system.
Thanks a lot. And how many high temperature ATES systems are operational currently? And would storage temperatures above 100 degrees Celsius be feasible?
I'm not sure if it is really possible above 100 degrees, because it's already a challenge at the moment to choose right materials and to work in a safe way. In the Netherlands now, one system with about 95 degrees is now in operation. So during the last months, we have charged the system with heat, and in January we will start with the first abstraction of this heat. There are some other systems which has a lower temperature range between, let's say, 40 and 60 degrees, but this is the one which works up to 90 degrees.
And do you have any calculations how much heat in percentage stays in the aquifer for reuse and how much dissipates out of the aquifer?
Yeah, that's one of the calculations you perform in the beginning. It depends, of course, on the depths, on the energy concept, and on the temperature range. But at the moment, we see that storage percentage between 60–70% would be reasonable. And of course, that also depends a little bit how long you will take the system in operation. But we think that the percentages are relatively high and maybe can also go a little bit up to 80%.
Okay. Do you encounter any issues regarding ownership of subterranean heat? Are there any licensing issues in the Netherlands?
Yeah, as far as I know, and if I understood the question well, then when you have your permit, yeah, the subsurface belongs to the government, but you may use it when you have the permit. So the surface is yours, and then the subsurface is of the government, and you need a permit to apply the system. But if you have the permit, you can make use of the system unlimited, so there's no restriction in time. And that gives the industry a good indication that they can work for many years with this technology.
Thank you very much. For the end of our session, I would like to ask all the speakers which are still in the room to switch their videos on. And I would like to ask you to give a last comment and maybe a conclusion of today's session. I think David already had to leave for giving a lecture. So I would ask Javier to give a last comment.
Okay, now I'm admitted. Okay, this was terrific. I learned a lot about different things I wasn't quite aware. And I think it was a terrific update about the potential of innovation in different areas of geothermal activity, in quite different also niches. And I think this gives a lot of hope, no? that our technology, that our is going to be a substantial contribution to the transition. There's more and more awareness also in our country here and in many others. And I think we are in this breakthrough, I think, in the next years of being really a key part of this transition. So I see this day to day with a lot of hope and a lot of good preparations.
Yes, thank you very much. I think the same. Ignacy, what would you say for the last conclusion or comment?
Oh, thank you. Just to give a message of conclusion, I mean that at least in Catalonia, after some years of geothermal energy has been somehow stopped. Let's think that we are entering in a very good scenario or decade that we will see that shallow geothermal energy will be implemented more and more in the public sector and the private sector, I hope.
Thanks a lot. And I give the stage to you again, Bas.
Yes, thank you. I'm very happy with this session. I think the challenge is big, is huge. There's so much to do to so many challenges in this energy transition. And I think heat is, of course, about 50% of all the energy we need. So it's a very important topic to look how we can improve it and how we can make use of our natural sources and to work in a sustainable way. And I really hope that, and I see that in so many countries there are initiatives to work and to implement it. And I also see during the last years there are a lot of struggles, but we have to continue and to move on. And then I think we will be successful, especially when we all work together.
Thank you very much. I would like to thank all of you for this great presentations and discussions. And I wish you all a good lunch break now and already Merry Christmas.
Thank you very much. Bye-bye.
Goodbye.
Bye-bye. Thank you.
Thank you. Merry Christmas to all of you.